Well, hello there everyone, welcome to lesson 3 of Mmaths Online. We've got a do now for you to do. You need to write down your 3 times table up to 12 times. So write down the whole equation, 3 times 1 equals, 3 times 2 equals, 3 times 3. Okay, away you go. Okay, all done. Did you get them all down in time? 3 times 1 all the way up to 3 times 12? Okay. So today we are going to be looking at area. In our last lesson we looked at perimeter. Today we're moving on to area. We're going to compare shapes based on length and area, and you're going to use area measurement appropriate to the problem. So you're going to solve some area problems today. Okay, as a warm-up, just got some shapes there. I want you to work out the perimeter. So just a bit of revision from last lesson. There's 4 shapes there. I want you to work out the perimeter. That is the distance around the outside of those 4 shapes. Away you go. 2 minutes.
To learn, you have.
Okay, all done. How'd we go? Hopefully Yoda didn't disrupt your attention there. He's there just as a training tool for you to train your focus so you don't get disrupted. Okay, got the answers there. So 44 centimetres for the first one, 36 for the second one, 22 centimetres for the third, and 26 centimetres for the fourth shape. So hope you got those right. If you didn't, just go back and check your count. Okay, just a recap from yesterday. Perimeter measures the distance around the edge of an object. So there's the object there on the screen. The perimeter is that red line that goes around the edge of the object. So moving on to area, Area measures the area, the space, inside an object. So we're talking about a two-dimensional object now. Okay, so there's the object again. Okay, and there's the space inside the object, which is what area is. Okay, when we're measuring perimeter, we're measuring the length of lines. So that can be the straight or the curved edge, the boundaries of shapes. So on the slide here, we'd be measuring around the outside of that square. Okay, but it's only one length. You're either measuring the width or the length or the height. Okay, so there's only one measurement. You're adding up all the measurements, but you're adding up one measurement at a time and adding them up. So the way we write perimeter is in centimetres, metres, kilometres, left out millimetres there. Okay, so that's how we measure perimeter. But when we move on to area, okay, we are measuring the space within an object. Okay, so you have the perimeter, which is a red line, and you're measuring the space within that object. So what you are doing now is you are incorporating two measurements. You're incorporating the width or the length, if you want to call it that part there, and you're also incorporating the height. It doesn't matter what you call those two dimensions, but we're actually starting to work in two dimensions. We're not just working in one straight line, we're having to incorporating another part of the shape. So we've got the length and we've got the width. We're incorporating those two measurements to make up the whole space. So when we're writing down area, we're writing down centimetres squared or metres squared or kilometres squared. So whenever you see a measurement with a square, which is a little 2 just a little bit above the measurement, that you know they're talking in area. So because that little square, that number 2, represents two dimensions. Okay, so with area, we're looking at width or length, and we're also incorporating height now, so we're encompassing the whole area. Okay, why is it called squared? So if you look at the screen now, we've got a grid, okay, and it's been divided up into 1 centimetre squares. So just imagine that each one of those squares is 1 centimetre, so 1 centimetre high by 1 centimetre wide. That means the area of each little square is 1 squared centimetres, just like the blue square there. Can you find the area of the green rectangle by counting the squares? So as you can see there now, it's counting up all the squares inside that area. So they're all 1 centimetre squares. And then the answer will be 32 squared centimetres. So that means there's actually 32 of those 1 centimetre squares that can fit inside that shape. Got another one here, another shape. And there you can see that shape has 15 of those 1 centimetre squares that it can fit inside that space. So that means that shape there takes up 32 square centimetres, and this shape here takes up 15 square centimetres. Okay, got a little activity for you now. As you can see, we've got 3 shapes on the right hand side. We've got a rectangle, a triangle and a square, and we've got a grid on the left hand side. Now we're going to presume that that grid has 1 centimetre square, so each one of those squares is 1 centimetre squared. What I want you to do in this activity is I want you to look at those shapes, and I want you to try and make a prediction or an estimate of what you think the area of each one of those shapes are by trying to line it up on the grid on the left hand side. So pause the video and take a minute or two just to see if you can estimate the area of those 3 shapes. Rightio, how'd you go? Let's have a look at the first shape. So I've got the rectangle up here. What did you get for the rectangle? Let's have a look. Okay, so we superimpose it over the grid. We've got 1, 2, 3, 4, 5 across, and we've got 1, 2, 3, 4, 5, 6, 7. Okay, so if we added up all those squares, in total we'd have 35 square centimetres. The next one, got the square. Okay, for 1, 2, 3, 4 across, and 1, 2, 3, 4 down. Because it's a square, all sides are equal. So if you added up every one of those squares, there's 4 lots of 4, which is 16 squared centimetres. And the last one is the triangle. So the triangle's a little bit trickier. Okay, so if you see here with the triangle, what we can do is we can try and count the full squares first. So we can consider that being a full square. 1, 2, 3, 4, 5, 6, 7, 8, 9. I've just put the answer up there. Then we've got maybe 10, 11, 12, 13, 14. I've estimated about 15 square centimetres. So if you had 14 or 15 squared centimetres, even 13, you're pretty well on the ball there. And there you have it. Okay, here we've got some more shapes for you. So go ahead and work out the perimeter of those shapes. Just quickly pause the video and write down the area of those 4 shapes. Okay, bring up the answers for those. We have 18 centimetres squared for the rectangle there. We've got 25 centimetres squared, 16 centimetres squared, and for the triangle, I estimated roughly about 10 centimetres squared. So if you have 9 centimetres squares, 10 or 11 centimetres squares, you're pretty well on the ball there. We've got 4 more shapes there for you. So go ahead and see if you can work out the area of those 4 shapes. Quickly pause the video and work out the area. How did you go with those 4 shapes? Okay, bring up the answers now. We have 36 centimetres squares for the big rectangle, 15 centimetres squared for the triangle, 15 centimetres squared for this rectangle here, and 32 centimetres squares for that rectangle. Now the question you need to ask yourself this time is, how did you work out the area without seeing the boxes? So with these 4 shapes, you've got the shape superimposed over the top of the grid, but you actually can't see each individual box. So how did you come about getting that answer without being able to count all the individual boxes? Okay, let's look at this first rectangle here on the left hand side. Okay, we can't count the actual individual square centimetres because the shape is in front of it, but what we can work out the width and the height. Okay, so if we count across, we have 1, 2, 3, 4. Okay, so that means it's 4 centimetres across, and there's actually 4 columns. Okay, 4 1 centimetre columns for the width. If we look at the height, we've got 1, 2, 3, 4, 5, 6, 7. Okay, so the height is 7, but that 7 makes up 7 rows. So when you combine the columns and you combine the rows, you end up with your 1 centimetre squares. Now we could now go and add up all those 1 centimetre squares, and if we counted each one of those 1 centimetre squares, it would total 28 centimetres squared. But there's a quicker way to do that, okay? And if you look at the relationship between 28, 4 and 7, can anyone think what the relationship is there, if they know their timetables well? Some of you might have got it. Yes, 4 times 7, so 4 multiplied by 7, gets you 28 centimetres. Let's look over onto the second shape here, the square. So with the square, we're counting across. We've got 1, 2, 3 across. Okay, that makes up your 3 columns, which means you've got 3 1 centimetre columns. And if we add up the height now, the rows, we've got 1, 2, 3 down as well, and that makes 3 rows. So we've got 3 columns. We've got 3 rows. Now we could count up each one of those 1 centimetre square boxes now, which would add up to 9. But we don't have to count up each individual square. All we have to do is, yes, multiply 3 times 3, and that will give you 9. Okay, what does that mean? Well, it means we can apply some rules when we're calculating perimeter and area, when we're doing our measurement. Well, we don't have to count up individual squares. We can use some rules to work out our measurements. So the first one is perimeter. Okay, so the rule for perimeter is you just add up all the sides. So if If you've got all the measurements for the shape, you just add them all up together, you create the perimeter and the length around the perimeter. Now for area, okay, we are multiplying the two dimensions, whether that's length or width, or whether it's length or height. Okay, with circles down the track, when you learn about circles, it might be radius, diameter, okay, but it's normally you're working with two measurements. So in particular with squares and rectangles, you are going to multiply either the length and the width or the length and the height. So you've got two rules there to work with, so you don't have to go and split it all up into little cubes and count all the cubes up. Okay, so your exit ticket now. I've got three shapes on the screen there. Go ahead and see if you can work out the area of those three shapes. Make sure you pause the video before you work those out. Okay, the answers. So, the top shape here, got 2 centimetres and 6 centimetres. I've just put the grid in there. So, if you didn't know the rule, you could add up all the squares in the shape, but because we have our rule, which is length times width or height times width, we just multiply the two measurements. So 2 times 6 equals 12 centimetres squared. Okay, the next shape, we have 4 by 4. There you go. If we had the grid there, we could count each one of those 1 centimetre squares, but we don't have to because we've got a rule now. So all we do is multiply the height by the width or the height by the length. Remember, it doesn't matter what you call these sides. So 4 times 4 equals 16 centimetres squared. Remember, always say squared, because if you don't say the word squared, if you don't put that little 2 up there, then you're not talking about area. And the last shape, we have 6 centimetres wide by 3 centimetres high. If we put the grid in there, we could count out all those individual boxes, but we just use our rule. 3 times 6 equals 18 squared centimetres. Rightio, homework. First task, I want you to go back through the video and look for the crazy person with the red hair. So I want you to go back into the video, find that crazy person with the red hair, and I want you to write down what was on the 2 slides that this crazy person appeared in. So this person appeared in 2 of the slides. I want you to write down the information on those 2 slides. And the other thing is, what else wasn't right about the video? So go back through the video and have a look and see what was peculiar about it. And if you can work out what was weird about the video, I want you to email me and let me know. Again, feedback. Take photos of your completed work and email it to me at bsteph10@eq.edu.au. Okay, so it's important that I see some of this good work being done. And I will see you next lesson.